Hi everyone, I'd like to welcome you to Mr. Q Does Math, the video show where Mr. Q, that's me, does math problems. Hey guys, so today we're going to be working on solving quadratic equations with square roots. So the first thing I want to do is take a look at a really basic example. So let's say you're given something like x squared equals 25 and you're asked to solve this. So basically when we see x squared, all that's saying is that you're taking the number x and multiplying it by itself one time, because there's two total x's here, so that's why the exponent is 2, and you get 25. So let's start by looking at the factors of 25. To get the factors of 25, basically ask yourself what numbers multiply to give you 25. There's going to be 1 and 25. 2 doesn't go, 3 doesn't go, 4, and 5, and 5. So what we were looking for is two numbers that are the same that multiply together to give you 25. These are not the same, and 5 and 5 obviously are the same. So we can say for certain that when you're looking for x squared equals 25, that x equals 5. But we're not done, because if you remember from your order of operations days, if you have a positive number and you multiply it by another positive number, you'll get a positive solution. So in this example we had the 5 multiplied by the 5 to give us 25. Now if you have a positive number times a negative number, that's always going to give you a negative answer. So that's not going to work here, because a positive 5 times a negative 5 is going to be negative 25. But what if you have a negative number times another negative number? What's that going to be? That's actually going to have the negatives cancel, and so you'll have a positive number. So for this example here, we have 5 and 5 that work, but what about negative 5 and negative 5? So if we multiply negative 5 times negative 5, we're going to get 25, and the negatives cancel, so you'll just have 25. So not only does x equals 5 works, not only does x equal 5 work, but so does x equals negative 5. So we would write our final answer to the problem x squared equals 25 as x can be either negative 5 or 5. Before we go jumping into any problems, I wanted to show you guys what happens when you graph the function y equals x squared, because it's a special kind of graph, and I feel like if you see the graph, then your answers in the future, why there's a positive and a negative, will make sense why they are that way, and it's just a cool thing to kind of look at. So let's construct the graph by making basically a t-table first. So we have y equals x squared. So you have x and y. I usually like to go from negative 3 to positive 3 whenever I make a t-table. So this is negative 3, negative 2, negative 1, 0, 1, 2, 3. And all I have to do is plug these x values into my equation to get my y output. So y equals x squared is basically saying y equals the value x times itself once. So x times x. So this would be x times x, which equals negative 3 times negative 3, which is positive 9. So this is going to be negative 2 times negative 2, which is positive 4. Negative 1 times negative 1, which is just going to be positive 1. 0 times 0, still going to be 0. 1 times 1 is going to be 1. 2 times 2 gives you 4. And 3 times 3 equals 9. So now we have the points that we need to plot. Now let's go ahead and graph this. So I'm just sketching this. You could use graph paper if you wanted. I just want to show you the shape of the graph. So I'm just going to kind of sketch it. So for our y values, label our x and y axis. Our y values go all the way from 0 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And our x values go from negative 3 to positive 3, so 1, 2, 3 negative, 1, 2, 3 positive, and this is 9 up here. So let's graph. Negative 3, 9, this is going to be a point here. Negative 2, 4, so back to up 1, 2, 3, 4. Negative 1, 1, so back 1, up 1. It's going to be right there. 0, 0, it's going to be right here. 1, 1 should be there. 2, 4, it's going to be right about there. And 3, 9 should be about there. So my scales definitely weren't that perfect here at all. But what you should see is roughly a V shape that forms. And basically, even though our values for x here are negative, we still get a positive value out. Negative x, positive value out. And the opposite number, so negative 3 and 3, correspond to the same y value. So that's why when you look at this graph, you can actually say it's symmetrical with respect to the y-axis, because if you cover up this, what you have on this side, if you reflect it over the y-axis onto this side, is going to give you the same exact thing. Now, it doesn't look perfect because, like I said, I just sketched the graph, I plotted the points, but that's the V shape that this graph will most times have, actually will have every time. So something else that I feel helps when we're solving quadratics by taking the square roots is the idea of the perfect squares and what they can tell us about the number that we're taking the square root of. So the perfect squares are numbers that you can basically multiply by themselves to get a perfect square. So for example, 1 squared is a perfect square because it'll give you 1. 2 squared is a perfect square and it'll give you 4. There's no decimal point values, they're just whole integers. So let's do the perfect squares for the numbers, for the integers 1 through 13. So 1 squared is going to be 1, 2 squared is going to be 4, 3 squared is going to be 9, and again, if you forgot for whatever reason, when you square something, you're just multiplying it by itself once. So this would be 1 times 1. This would be 2 times 2, and so on. 4 squared is going to be 16. 5 squared is going to be 25. 6 squared is going to be 36. 7 squared is going to be 49. 8 squared is going to be 8 times 8, which is 64. Let's see. 9 squared is 9 times 9, which is 81. 10 squared, which is 10 times 10, which is 100. 11 squared, which is 121. 12 squared, which is 12 times 12, which is 144. And 13 squared, which is 169. Okay, so now that we have our nice long list of our perfect squares, what does this basically help us to do? And for me, it really helps us to estimate when we have a number that we're taking the square root of and what our answer should look like. So let's say they ask you for the square root of 6. So the square root of 6 would fall somewhere between the square root of 9 and the square root of 4. So we could then say that the square root of 6, which is going to fall somewhere between the square root of 4 and the square root of 9, should be approximately between 2 and 3. So if you put this into your calculator and you end up getting something like 4.89 or 5.89 or 6.12, 9.12, you know you've done something wrong, because according to our chart, the square root of 6 should fall somewhere between 2 and 3. So just to do a couple more examples of stuff like this, if you had to take the square root of 20, that would fall somewhere between 16 and 25, and that means that the answer to the square root of 20 should be somewhere between 4 and 5. Okay, so what if they asked you, oh, what's the square root of 150? Well, it's not going to be a perfect square, but you know that it's in between 144 and 169. So it should be somewhere between 12 and 13. I went back and I used my calculator to find the square root of 6 and the square root of 20. And as you can see, we had estimated that the square root of 6 should fall between 2 and 3, and it actually works out to 2.449489, so we were right on there. The square root of 20 we estimated to fall between 4 and 5, and the calculator tells me that it's 4.472135.9, and the decimal keeps going on, so we were right on there. And the square root of 150 is 12.27487 ... on into infinity. So that's why looking at these perfect squares is just a really nice little tool to give us an idea as to what our worked out values should be.